Great, good morning. This is ACA for Monday the 28th. This is a warm-up. Please complete it if you're at home, writing down your answers and let me know you're ready. Okay, on this first one, we're going to compare our variable, and we're going to compare that to what in this problem? We're going to compare it to 1800. Okay, so first you ask yourself, can it be equal to 1800? Yes, it can. So it's going to have that line. But then it has to be over, or does it have to be less than? It has to be less than. Very good. Okay, so that's your inequality. Which numbers work? 1799, did that work? Yes. What about 1800? Yes, because it can be exactly equal to 1801. No. Can someone explain in words how that graph would look?
Like
how? Explain what would the graph look like?
So there would be a
filled in dot.
And the arrow would be going
to the left. Do y'all agree with that?
Yes.
I agree. Okay. Minimum speed is 40. Okay. Our speed, we're comparing it to what?
40.
We're going to compare it to 40. Can you be exactly at 40?
Yes.
Yes. Okay. Can you be over 40 or under 40?
Under 40.
In this one, it says the minimum speed. You don't see this sign too much, but this one, there are minimum speeds. It's not a speed limit sign, it's a minimum speed. So should I be above 40 or should I be under 40? I should be above 40. Okay? These aren't too common, but they do exist because I don't know if you've ever been in the car with your parents and like there's that one person going way too slow. If you drive too slow, it actually becomes a safety issue, and so that's why they do have minimum speeds. Most of the signs you'll see are speed limits where you can't go over something because there's also safety for that. But this is a minimum speed. So could I be driving 39 and be safe? No, minimum speed. At the least it should be 40. But 40 and above is what we want. Okay, 39, 40, and 41. Open or close circle. Close. And Lucy, which way is it going to go? To the right. Okay? Hopefully that is all review from last week. If you did not get that homework done last night, can we get it done tonight? Absolutely. You guys, like this stuff is so foundational. Okay? From the homework, for those few of y'all who did do it, were there any questions?
Yes.
What? Okay? We were just determining which ones make it true. So we were plugging them in. Again, that semicolon breaks it up. If I have the inequality 32 plus 8 is greater than 44, which numbers made it true? Only 13, and that first one made it true. Can inequalities have more than one answer?
Yes.
Yes, they can. Okay, if we look back, we had several numbers who made it true. Okay, that is the difference. That's a big difference between equations and inequalities. Okay, anything else? All right. So we are going to look more at inequalities today. With the inequalities, remember how when we had equations a few weeks ago, or by a few weeks, I mean last week, we were trying to find the value of x. So if I put x plus 7 is equal to 10, do y'all remember how we solved these?
Yes.
What did I do?
Put
the line, very good.
Subtract 7.
You want to get x by itself, so we would subtract 7 and do this, very good. We got x is equal to 3. Right? Okay? That's what we're doing today. It's very similar, but it's got its own twist since it's inequality. For the most part, it's the same exact step. Can you get your head up, please? Thank you, Leon. Okay? So let's just look at a few together. So starting with addition and subtraction, again, you know those are inverse operations. They undo each other. Let's look at this. So I'm not going to fill in a lot of the stuff on these notes. You'll just follow along with me. So when you add or subtract on the same side, it should say true. Do we agree with this statement that 5 is less than 9? Is that a true statement?
Yes.
Great. Check. What about this one? 11 is greater than 6. Is that a true statement?
Yes.
Yes. I'm not going to bother graphing these out because y'all got it. But let's look at what happens. It says, now let's add 3 to each side. So sort of like the equations, I'm going to split it in half, and I'm going to add 3 to each side. That new inequality is going to read 5 plus 3 is 7. 5 plus 3 is 8. 9 plus 3 is, and bring down that inequality sign. Is 8 less than 12? Did the inequality stay true? Yes, it did. Okay, even if my sign was the other way, 11 is greater than 6. Again, let's add 3 to each side, plus 3. What's my new inequality going to read? 14 is greater than, is that still a true statement? Yeah. Okay, so with inequalities, I can add and subtract the same thing to both sides, it stays balanced. Okay, so if I spice it up, I have 5 plus x is equal to 9. Whenever I have something like that, my goal is always to get x by itself. Okay, so I'm going to sort of cut it in half. How, or what do I need to get rid of to get x by itself in this case? I need to get rid of the 5. How do I get rid of that 5? Minus 5. Subtract 5. Okay? Whenever I do on one side, I do to that other. Very awesome. Okay, let's cancel some stuff out. 5 and take away 5, it cancels out. I have x. 9 minus 5 is 4. But I already heard someone say equals. It's not equals. It's bring down that inequality sign. X is less than 4. Okay? So that means x can be any number that's less than 4. If I use 3 up in that original one, 5 plus 3, which is 8, is that less than 9?
Yes.
Okay, what if I use another number? If I use negative 1, 5 plus negative 1 is 4. Is 4 less than 9? Yes. So this right here, I'm going to label it. This is it's called a solution set. It's called a solution set. It's the set of all numbers that are my solutions. Remember, solutions make it true. Okay, that is my solution set. If I were to graph that, x is less than 4, I'm going to have 3, 4, and 5. Could I put 4 in? Is it an open or closed circle?
Open.
It's open because I cannot include 4. Correct. And 4 isn't greater than 4 or less than 4. And then I want all the numbers which way? Would 3 make that true or would 5 make that true? 3. So to the left. Yup. Okay. Similarly, I've got this inequality. X minus 11 is greater than 6. I want to get x by itself. I see what operation? I see subtraction, so I use addition. Plus how much? 11. Plus 11. Plus 11. Okay, so that's x. 17, and then bring down that line. Okay, so 17, yeah, sure. 18, 16, no, it's a 17. My handwriting is beautiful. Okay, open or close circle?
Open.
Open. Remember, if there's no line, it's open. And then I want numbers greater than 17, so 16 or 18. Towards the 18. Here, T? Yeah. Do you see how it ties in, like the equations and the inequalities? All right. So I want y'all to try 1, 2, and 3. Split them, solve them, and graph them. Take a few minutes. You got this. Okay, pause and play when you're ready. All right. I saw many of y'all on that first one. I need to do what to my side? Minus 7. Yeah. Okay, so I'm left with x is greater than or equal to, or equal to 10 minus 7 classes. 3. Okay, why didn't you talk like that? 2, 3, 4. Open or close? Close and to the right. Okay, hopefully more than this one has this. Okay, good. Okay, on that next one, I see what operation? And I need to add to both sides. Okay, we said we needed to add 3.
Can you get them fixed before they come up?
All right. So if I have negative 9 plus 3, that's going to give me negative 6. Bring down that inequality sign, and then I'm left with what on the other side? S. Okay, put negative 6, negative 7, negative 5. Is it an open or close? Open. And then which direction? To the left. Okay. And then lastly, what operation do you see?
Subtraction.
I see.
Addition.
Addition, I can do it with subtraction. N is less than or equal to
-7.
-7. Okay? -8, -7, -6. Open or close?
Close.
Close. And
To the left.
to the left.
That is
To the left. Yep. Alrighty. Alright, now we can look at, huh? Alright, here we go. Let's keep going. Multiplying and dividing. So, again, starting with inequalities that are true. Is 24 less than 40?
No.
Is 24 less than 40?
yeah.
Okay, is 24 less than 40?
Yes.
Yes, that is true. Is 4 greater than 2? Over here, is 4 greater than 2? Yes, it is. Guys, focus. Focus. Thank you. Okay, so it says we're going to do multiplication and division to see if that is true. Okay, it says to divide each side by 4. Miss Lyle's going to do it based off of these. Since I don't actually use these graphs right now, I'm just going to divide each side by 4. Again, I like to use those fraction bars because it's just easier to write it. I heard Hudson say 24 divided by 4 gives me 6, and then 40 divided by 4 gives me 10. And I'm going to fill it in those bubbles. Is that statement still true? Okay, it is still a true statement. Check. So if I divide them both by 4, we're good. Okay, let's multiply. Okay, let's see how that works over here. Again, cutting it in half, multiply by 2, multiply by 2. 4 times 2 is 8. 2 times 2 is 4. Just bring down that inequality sign. Is 8 greater than 4? Yes. Again, nothing is changing. But there is something about to change. Your life is about to change. So thank you so much. Thank you so much. All right. So let's look at this. Starting with that original inequality. Is 24 less than 40? Yes. Still a true statement, but something's about to happen, and so we need to pay close attention. It says that now we're going to divide by -4. Instead of dividing by a positive, we're going to divide by a -4. I'm going to have to squeeze this in. I'm going to have to write it over on, say, -4 divide by -4. Okay, 24 divided by -4. Signs are different, so it's going to be a -6. Okay, 40 divided by -4, signs are different. -10 wins it. Okay, and then they brought down that less than sign. Again, I'm sorry that it's really tight in there. So let's look at that. 6 is less than -10. I am going to use the graph on this. Okay, so let's say, okay, we're in the negatives. So let's say like 0 is over here, and we hit -6, 7, 8, 9, -10. Miss Lytle always says that less is on the left. But this one says that -6 is less than -10. Is that a true statement? That's not true. Okay, which one is less, -6 or -10? No. -10 is less than. This is a false statement. That's not true. When I divided by a negative, it didn't say true. Okay, let's look at the multiplication. Let's look at the multiplication. Let's multiply, it says, by -2. Okay, okay, times -2 times -2. 4 times -2, signs are different, so negative what? Yeah, but -4 times 2, -8. Okay, 2 times -2, that's going to be a -4. Okay, again, thinking if 0's over here and I'm going to my negatives, -4, and then -8, which one's less? -8. So it should be eating the -4, okay? This is, again, false. But how? Okay, what's different on this one is I'm doing what? Negative, but and specifically what with those negatives? I'm doing which operation? Multiplying and dividing by negatives, okay? It's not working for that. Okay, so we need to think about what could we do to these inequalities. I'll circle in green. What could I do to these inequalities to make it true? It's a quick fix. What could I do? Like what? The sign, okay? Just, that's a quick, easy fix. whenever you multiply or divide by negative, you're going to flip just the inequality sign. You're going to leave the numbers where they are and just flip the signs, okay? So you need to flip the sign, okay? So instead of on this first one, instead of less than, the flip side would be greater than. On negative 8 and 4, it was greater than, make it less than. Okay? And then they are true. Okay? That's the only difference. All the rest of it is smooth sailing, but whenever you multiply or divide by negative, an alarm should be going off in your head, saying, alert, this does not work. Okay? So you flip the inequality sign. So let's just go practice with the algebra. Okay? Let's go look at these. So again, 4x is less than 12. I want to get x by itself, so ask yourself what's happening. What operation is happening? 4x. What operation is that? Multiplication. Do we agree with that? When they're right next to each other. I undo it with division. Divide by 4. Okay? I'm not dividing by a negative, so I don't need to do anything to the sign. I can just leave it as is. 4 divided by 4 cancels out. I'm left with x. 12 divided by 4 is 3. X is less than 3. Okay? So, any number less than 3. What's the number less than 3? 2. If I plugged in 2, would it work up here?
Yeah.
Yeah, because that would be 8 is less than 2. Yeah, that works. That works. Okay, so let's graph it. 2, 3, 4. Open or close?
Open.
Open. And then
To the left.
to the left. Okay. Again, x over 8. When it's over, that means division. Undo it with multiplication. Times 8 times 8. Okay, so on the first, bro. Yeah, you're good. Okay. Slash that out. X is, do I need to flip it? Do I multiply by a negative? No, so I just leave it. And then 3 times 8, 24. Yeah. So, okay, numbers greater than 24, like 32. If I did 32 divided by 8, that gets me 4, and that's greater than 3. So that works out, okay? So 23, 24, 25. Open or close?
Open.
Open. And 23 or 25.
Great.
Okay? Are we sort of kind of following?
Yeah.
Is better than no. Okay? Is better than no. For those of y'all saying no, again, ask yourselves, have I been doing all that I can to help myself? Have I been doing the homework? Have I been coming to tutorials? No. Okay? Then that's why you might struggle. Again, you guys as middle schoolers, as soon-to-be seventh graders, you have to take initiative for yourself. This is an elementary school where we baby y'all. You have to take that initiative. Okay? But keep up this good stuff. Y'all are doing good right now. Okay? Again, what's happening to x? Very good. Multiplication. I need to undo it with division. But alert, what's happening? I'm going to divide by -4. So whenever I divide by negative, what do I need to do? Flip. Okay? If you need to write it off to the side, so you remember.
Can you just do it at the end?
Do it at the beginning. Why would you do it at the end? Because then you're don't always forget out the last.
So you don't confuse yourself.
No, flip it at the beginning. If you want to, okay? I'm just saying, chances are you'll forget to. Do it at the beginning, because then it's done. Check. Okay, this cancels out. I'm left with x. 12 divided by -4. Signs are different. Negative wins it. -3. Okay, over here, it's getting divided by -8, so to undo it, well, I need to first, no, okay, what undoes division? Thank you. Multiply by -8. Now I'm thinking alert, I'm multiplying by negative, so flip the sign. X is less than -24. Okay, work on graphing those real quick. All All right, sorry, yeah, my kids were just like, these are the same problems. Yes, it's the same problems because up here, they were trying to do it side by side with the notes. Well, we already did it right? Because I don't like doing things wrong. So we already did it right. Okay, but if we needed to fill in this blank, we need to flip the sign. All right, because I already did it, like, I'm not going to make y'all do the same problem. All right, you're welcome. All right, so help me fill in these blanks. Help me fill in these blanks. When blank or blank, each side of the inequality by a negative number. Whenever we multiply or divide. Whenever we multiply or divide by a what again? By a negative number, the inequality sign must flip. It must flip for it to remain true. All right, so open up the packet. You're going to see, I hope these 4 problems. Try them out. Work at your desk, check with a partner. We're ready to go. All right, again, if you ever get stuck, just say what's happening, what undoes it. Okay, and number 1, what is happening? We undo it with division. Okay, undo it by dividing by 110. I already heard some people say, well, that can be, y'all said it's not possible. We do know it is possible, but what kind of number is it going to be? It could be a decimal, or it could be, honestly, you could leave it as a fraction. Okay, if you did, I honestly left it as a fraction. I just simplified it. 80 and 110, I could divide them both by 10, right? I could, because they both end in a, it is 0. They are both divisible by 10. I honestly just left it as 8 over 11. Okay, I just left it as that. Now, let's think. 8 over 11, what 2 whole numbers is that going to be between? What 2 whole numbers?
9 and 7.
I disagree. 8 over 11. The fraction 8 over 11. No.
9 and
Think of a fraction bar. 8 11.
9 over 10.
Pause. If I wanted to put a whole number on each side, y'all are just guessing numbers. Think of if I turn that into a decimal. Would that even be 1 point something?
Yes.
No, I don't. If it was 1 point something, I would have more in my numerator. It's going to be between 0 and 1. This is going to be 0 point something, right? It's not even a full whole. If I have a whole, I only have 8 11ths. I only have a fraction of a whole. So this is going to be between 0 and 1. Okay, so I'm not going to be too specific. I'm going to put it like right here and say that's 8 11ths. I'll call it 8 11ths. Pause. Let me finish. Is this going to be an open circle or a closed circle? Open. It doesn't have the line. Open. And then it's all numbers less than. So it's going to go this way. Okay? Guys, I cannot emphasize enough. Yes, that was a rational number. Yes, it was a little spicy, but you still need to be able to have that understanding what 1 whole versus no holes looks like. Okay, 8 11ths is a fraction. It is a part of a number. It's not even a full 1. Okay, let's go back. I will say that is probably the spiciest one today, but you still need to understand it. Number 2, what is happening? Division. We undo it with multiplication. What are we going to multiply it by? And what should be happening in our head right now? Flip it. Flip. Okay, don't wait to the end. Go ahead and do it right now. Okay, times -6 times -6. This is going to cancel out. I'm left with x, and then -6 times -6. Positive again, 42. Oh, I didn't. I thought I did. See? This is why I got
That's why you wait for me.
Thank you. Okay, I just couldn't see it because I put it over it. This one, please. Thank you. I do know what I'm doing. Okay, open or closed? Closed, and then towards the 41. Very good. Okay, number 3, Jackson, what operation's happening on number 3? I disagree. What, Rory, is happening on number 3? Multiplication. Class, we undo it with division. Okay, divide by 7. Do I need a flip on this one? No. Okay? Just because there's a negative doesn't mean I'm flipping. I only flip if I multiply or divide by negative. I'm dividing by a positive number. Okay? So this is going to be x. I leave that sign. And then when I divide, I get
-8.
-8. -9, -8, -7. Open or closed?
Open. Or close
Because of the line. And then which numbers are greater than -8? -7. Very good. Okay? And lastly, of course, a word problem we'll do real quickly. Joanna's parents gave her $10 per week for her lunch money. She cannot decide whether she wants to buy or pack her lunch. If a hot lunch at school costs $2, write and solve an inequality. So I need to write and I need to solve. To find the maximum number of times per week Joanna can buy her lunch. Okay, so we're talking about each time she buys a lunch, it costs how much dollars? 2. And since it's each time, what operation is going to be that? Yeah, so we're going to do 2 times however many times she buys her lunch. Y'all good with that? And what are we comparing that to? We're comparing that to $10. Can she spend exactly $10?
Yes.
Yes, she can. Okay, does she need to go over 10 or stay under 10? Under 10. Okay, so we wrote for inequality, now we need to solve it. What operation is happening? Undo it with division. Very good. Divide by 2 by 2. Okay, tell me what I'm left with. 5 over here. X and less than or equal to. Okay? Are we understanding how that works? And does that make sense? What is the maximum number of times you could buy a lunch? 5 lunches maximum. That's also, yeah, that makes sense too. Unfortunately, not all word problems make exact sense like that, but yes, this one does. Okay, so what you're gonna do, there's probably not time for both partner practice and the homework, but please work on that. Guys, please, for the love of the title, do it. Do it. Thank you and good night.